Chapter 17 Test of Significance. In this video, I am going to explain this example. The mean annual expenditure per 25 to the 34-year-old consumer for healthcare is 1,468. This includes health insurance, medical services, and drugs and medical supplies. Students at a large university took a survey, and it was found that for a sample of 60 students, the mean healthcare expense was $1,520, and the population standard deviation is $198. Is there sufficient evidence at 0.01 significance level to conclude that their healthcare expenditure differs from the national average? First, let me write down all information. We know a sample of 60 students. Therefore, sample size is 60. And they talk about the mean of the sample, which is x bar. It is 1520. And population standard deviation is given, sigma 198. The last, the significance level, alpha, is 0.01. Right. Now go to the first step. Step 1, null and alternative hypothesis. What is the null and alternative hypothesis here? Now read the last sentence. Healthcare expenditure differs. Here we need to check if healthcare expenditure differs from the national average. What is the national average? 1,468. Therefore, our alternative hypothesis should be not equal 1468. Null hypothesis is mu equal 1468 and alternative hypothesis is mu not equal 1468. So this is the two-tailed test. Now go to the step 2. Step 2 is test statistics. Before we go to the test statistic, check the information. Check for sigma. If sigma is given, we can use Z0 test statistic. Here sigma is 198. That is the population standard deviation. Therefore, we can use Z0 equal x bar minus mu naught divided by sigma over root 10. So, we can plug these numbers to the test statistic. Here 1468 is the mu value undash naught. Undash naught mu equal 1468, that means mu naught. Then test statistic is 2.034. Once we have test statistic, we can go to the step 3. What is the step 3? P-value. Now how do we check the p-value? Before we go to the p-value, you need to check alternative hypothesis again. Why? P-value depends on the alternative hypothesis. So this alternative hypothesis is not equal. That is two-tailed test. Therefore, we should consider this for the p-value. That means the areas left to the negative z0 and area right to the positive z0. You see that the area less than or equal negative 2.03 and the area greater than or equal 2.03. So you can write down this 2 times probability z less than or equal negative 2.03. So then go to the table, you can find the probability for that, then multiply by 2. That is 0.0424. We know the p-value now. Then we can go to the step 4. Step 4 is decision and conclusion. How do we get the decision? We reject H0 if p-value less than or equal alpha. Therefore, we need to compare p-value with alpha. So what is the p-value here? 0.0424. Alpha is 0.01. Therefore, p-value is greater than alpha here. So what is the decision? Our decision is we do not reject H0. Then how do we get the conclusion? Then consider again H0 and HA. We do not reject H0 mean we agree with H0. which is null hypothesis. Then we can go with H naught. So what is the conclusion? Therefore, there is not enough evidence to support the claim that the average expenditure differs from 1468, that is the national average.